Welcome back. Our next talk is from Singularity to Apptainer and be presented by Forrest Burt. Over to you, Forrest. You're still muted.
Thank you. All right. Well, good morning, everybody, or good afternoon, good evening, depending upon where on the hemispheres of our globe you are. First off, a big thanks to the EasyBuild community and the EasyBuild maintainers the EasyBuild kind of contributors for putting on this conference here. We're very excited to be speaking at it and kind of have some news here about Singularity and Apptainer. So yeah, thank you for putting this on and for giving us the opportunity to speak. My name is Forrest Burt. I'm a high-performance computing systems engineer at Control-IQ. And I am here today with From Singularity to Apptainer. Singularity, as I'll kind of get into in a second, is kind of a big containerization platform that's used a lot in high-performance computing. And there's been some big changes that have kind of come to that tool and kind of that community here recently that I know myself and the broader Apptainer community are very excited to discuss. So without further ado, I will go ahead and jump right in. Really quickly, for anybody not aware, from Singularity, but what is Singularity? Singularity is a mature open source containerization platform that was specifically built for HPC use cases. It's been in development since about the mid 2010s or so. It comes out of LBNL here in the US. It's uniquely well suited among containerization platforms for high performance computing because it does a few fundamental things with containers different than a lot of other platforms. First off, Singularity favors what's called integration over isolation. In the complex environment of a high-performance computing cluster, there's a lot of specialized hardware and software that simulations and high-performance computing work relies on to be able to run optimally. These are things like high-performance interconnects like InfiniBand, that kind of thing, GPUs for general-purpose GPU processing, MPI software stacks for being able to run simulations across multiple nodes at once, and parallel file systems like Lustre, things like that. So these are all things that need to be able to be available to a container that's being run in a high performance computing system. And so rather than work to isolate the containers from the host and kind of the host's capabilities and stuff like that, Singularity really works to integrate all of those capabilities within the container so that software inside of those containers can be used to run workloads on high performance computing software optimally. So another big focus of Singularity outside of kind of enabling high performance computing use cases is security. So Singularity features containers that are signable with GPG keys. It features containers that are encryptable with either an RSA key or a password. And another part of that security model is kind of the way that Singularity operates in general. Singularity has a single runtime and it uses what are called Singularity image format containers. These, as opposed to something like Docker, where you have kind of a daemon-based system, and it's a little bit, there are well-established security issues with Docker running in kind of a multi-user environment like you would have on a high-performance computing cluster that preclude its use in this case, just to use that as an example. As opposed to kind of a daemon-based system like that has to be operated with in a privileged manner. All Singularity does is just installs the runtime and then uses these Singularity image format containers to store things in them. So those are very easily portable. You can basically just ship those around because like I said, they're basically just a single file and you can treat them as such. There are other capabilities that CIFS kind of provide for HPC. There's some IO optimizations that can happen because of the squash-fs base that those CIFS are made off of. If you're say launching thousands of parallel processes on a high performance computing cluster, say they're Python, and every one of those is doing tons of, loads, imports, a lot of small file IO, that can really bog down a file system. And so another advantage of like the CIF and Singularity is that the squash-fs base that the file system for the container is built into, when all these kind of small file IO operations are happening, instead of it having to look all over a file system, it can basically just hit one single file and that squash-fs file system inside of it. So basically just becomes reading offsets out of a file and it becomes very fast. You can get the same optimization if you add a writable overlay. Singularity supports adding, I believe, an X3 image overlay to a container that allows then write, that gives a writable interface to the container. And because that's, once again, now just hitting one single image and basically just reading offsets in it, that runs fast as well, the writes in that case. So yeah, Singularity, basically it's built for high performance computing and kind of more secure workload use cases. It's deployed everywhere across enterprise, academic, and government institutions. I think the number I've seen is that there's estimated to be over 25,000 installs of it out there. So it's very widely used, and it has a pretty well established and mature community surrounding it. So now from Singularity to Apptainer. So the big news is that Singularity has been renamed to Apptainer and has been moved into the Linux Foundation. So first off, how did this happen? And what kind of led to this decision? So in early October of last year, a call went out to the open source Singularity community that was kind of about whether or not there would be interest in moving Singularity into the Linux Foundation. Like I said, this went out in early October to about 50 members of that community, and the results came back unanimous, 100% approval of this kind of pathway. This was kind of being looked at because Singularity is a mature technology, among other reasons, but just to give an example. Singularity is a mature technology, has a really good basis now being in the Linux Foundation for increased kind of collaboration and cross-pollination with places like the Cloud Native Computing Federation, the Open Containers Initiative, and the Open HPC project, and other organizations that are kind of in that Linux Foundation sphere. So this is really a good move for Singularity. It kind of brings it into a place where there's a lot more that can be brought into it and done with it. And kind of now, as a mature technology, it can start to, like I said, cross-pollinate with some of these other projects. Also, as a part of this move, kind of on more of the maybe enterprise and that kind of type of user side, as a part of this move, this was also endorsed by independent high-performance computing experts and entities and institutions like Sandia National Lab, Lawrence Berkeley National Lab, Fermilab, Intel, HPC now. So essentially, there was a broad basis of support for this move from both the open source Singularity community and the kind of more institutional, like I said, academic enterprise side of open source, the open source Singularity community. And so the new name was decided via vote. There were a few other options that were out there, but Apptainer ended up winning out by a margin. The name had to be changed because there is a bit of a complex history between the open source version of Singularity that became Apptainer and some other versions of Singularity that are maintained by a commercial third party. And because of those trademarks that are there, per the Linux Foundation's trademark requirements, Singularity couldn't be trademarked as a project inside the Linux Foundation. And so the name had to be changed, and it was decided on Apptainer by the community. So that's how the name was changed. There's a new management structure now that it's in the Linux Foundation, and this calls for a technical steering committee. And so Apptainer's technical steering committee is made up of 5 primary project maintainers, Cedric, Dave, Greg, Ian, and Krishna. I think we have a couple of them on here for the Q&A as well afterward. So thank you for being here. So there's a new management structure there. The technical steering committee follows policies that are laid out in a technical charter document. This document can be viewed online. It's essentially how the project will be maintained, how certain things have to be implemented if they are implemented, how it's governed, leadership, that kind of stuff. So, after the move, the new in a new repository, the old Singularity repo is going to be made read-only, or it already has been probably. Code will be, and progress will be working out of a new repository. So once again, that is the big news. We'll kind of back into the kind of stuff that's coming out with the first releases, but yes, as I said, very exciting Apptainer to be moving into the Linux Foundation, and a lot of people are very excited to see where this ends up going. So to kind of discuss the current status of the project, obviously it's kind of in a transitory phase right now as it's being moved between Singularity and Apptainer. There's a lot of work that has to be done to kind of enable that move to happen optimally. There's a release candidate that's actually out right now and just came out a couple that I will give some updates and just kind of a moment on what's in it and kind of what it does. But like I said, it encompasses some of the points that I'm about to make, but I'll elaborate in just a moment. So the current project activities include ensuring that there's proper backwards compatibility with Singularity. Obviously, especially with a name change, there's a lot of even just kind of code level things and directories, things like that, that have to somehow be accounted for now. especially if places are going to install Apptainer alongside a previously existing Singularity. So there has to be proper backwards compatibility with Singularity. So there's been a lot of work going on there. There's been some removal of some third-party commercially controlled APIs. Like I said, there's a bit of a complex history, and some of the code that was built into open source Singularity kind of referred to endpoints or remote areas, stuff like that. That's commercially controlled, and only open standards can be in it now, or can be supported in it now that it's in the Linux Foundation. So there's a couple things that have to be removed, like a remote builder functionality that would allow containers to be built remotely at a commercial company's site. There was a library resource that reached out again to a commercial company's container registry that it's also been changed, and there'll be other things I'll kind of get into in a second. But yeah, and then obviously there's a lot of planning for the future of the project and what features are going to be prioritized in the subsequent releases from here. I'll also go into this in just a second, but there's all kinds of different directions that the project wants to go, and kind of technologies that it can improve support for, and things that can be done with it now. So definitely a lot of planning that's going on right now, trying to figure out what wants to be included, that kind of stuff. This is all kind of based around the community meetings that happen every 2 weeks. I have the link at the end, but I'm not sure if it's going to be easy to get, so I will find a way to have that included here. But yeah, the community meetings happen every 2 weeks. So if you're interested, feel free to get the link to those and hop on them. There's a lot of interesting stuff going on right now. So we're definitely looking to grow the community and get the news out about what's gone on. So before I get into the release really quickly and kind of its features, just a quick digression about how the versioning of the new Apptainer is going to work. So the first release is going to be Apptainer 1.00. This Apptainer 1.00 release would have been Singularity, open source Singularity 3.90 if the rebranding hadn't occurred. But because the rebranding has occurred, obviously, this is now a new kind of path. It would have also been Apptainer 4.0 because there was some removed third-party functionality that was kind of some major stuff taken out if the reset to 1.0 hadn't been decided on. But it did, and so Apptainer is going to be based at 1.0 instead of continuing on from Singularity's previously existing versioning. And so Apptainer 1.00 has most changes made to Singularity Community Edition through version 3.94. And just to elaborate on what that means for a moment, as said, there's a third-party commercial entity. Singularity CE is a version of Singularity that this commercial entity has that is open source. So Apptainer 1.0 will have most of the changes that were made to that code base through their version 3.94. But there are a few differences. There was a removal of a certain NVIDIA kind of container option that was taken out of Apptainer for security reasons. And then there's other stuff that's been added to it, like, for example, instance checkpointing capabilities of containers is new in Apptainer, but hasn't been implemented in the other version yet. So to actually jump into some of the updates that have gone on in this first release candidate here. Like I said, this was released January 19th. This is currently in testing at the moment. It's hoping that this will convert to a release here pretty quick. As I alluded to, there are many backwards compatibility changes. I'm going to take a moment to grab my notes about the backwards compatibility to make sure that I have some valid examples here. So there's been all kinds of backwards compatibility changes that have gone on. Things like the executable itself has been renamed from Singularity to Apptainer. The configuration directory has been moved from Etsy Singularity to Etsy Apptainer. The per user configuration directory is now /.apptainer instead of or well, I should say home, home/Singularity instead of, It is now home/.apptainer as opposed to home/.singularity. So yeah, a few changes there to ensure backwards compatibility. Also, a lot of environmental variable changes. Singularity has a lot of ways that you can specify certain environmental variables to change the way things run or build. These have all been changed to kind of reflect the new name Apptainer. In a lot of these cases, if there's, like I said, there might be times where sysadmins might be installing Apptainer next to a previously existing Singularity install. There's different things that have been put into it to handle this, depreciation warnings, migration notices. In some cases, it'll take the previously existing files and move them to the new places automatically. So there's definitely been a lot of work that's done there to ensure that backwards compatibility. And so, yeah, a lot of changes there. As said, there were some third-party APIs that were removed from it. So there's a library, you can see there, that library tag. That's just a way to specify pulling down what you want the basically bootstrap method of the container to be. And so in that case, that library scheme would have referred to that third-party commercial kind of their container registry. And so that was removed. The default key server that when you are storing GPG keys for signing, that's been changed to keys.openpgp.org from the third-party key server that was out there and was built into it. The remote builder option has been removed. Once again, that was the third part, or that there's no protocol or interface that supports that outside of this commercial third parties. And so that's been removed. And there are a few other behaviors that have been changed. GPU support and how that is done is kind of been changed up a little bit, and I'll explain more about that on the next slide. How certain executables and libraries are found has been changed. So things like how it finds make squash fs, go, and other executables that it needs have been changed. Sorry, like I said, I have some notes here. I want to make sure I went over a few of these. Yeah, new options with GPUs, new changes to kind of some security container directives that it provides that allow you to specify whether you want, encrypted containers allowed to be run by Apptainer, signed containers, I believe, that kind of thing. There have been some kind of compatibility changes, like for example, labels from Docker and OCI images are now inherited. So some better support for Docker and, like I said, OCI images, and numerous other changes. There's a full list of them out there, obviously, in the changelog on GitHub. So if you want to take a look at that, that is out there and has more info. So also in this release candidate, there are a lot of new features. First off, there's container checkpointing with DMTCP. So this allows you to halt containers and checkpoint their state at that point for recovery later. I believe DMTCP also has compatibility with high performance computing systems. So this has interesting implications for how this type of checkpointing can be done in those type of environments. Because I believe it supports Slurm and InfiniBand interconnect, stuff like that. So that's pretty cool. There's some new options for Docker and OCI container compatibility. There's a new command line option that essentially collates a few different options, and I believe a couple other configuration options that it sets that are related to compatibility for those that makes those easier to interact with. Like for example, one I believe that doesn't mount the system home, but instead gives kind of like a dummy mount point to home. So a few different things like that. There's a whole new way to interface with NVIDIA GPUs through the NVIDIA Container CLI executable that NVIDIA has out there. Previously, GPUs would be like the library, stuff like that would be brought into the container, integration over isolation. Previously, that kind of stuff would be brought into the container through either, I believe, checking a predefined list of those of the necessary libraries and stuff, and then finding those on the system in a certain specified location, or it could use the NVIDIA Docker tool that NVIDIA provides to find those libraries on the system as well. So a couple different ways there were previously to do that. Now you can use the NVIDIA Container CLI, and there's a few other options that are kind of surround that as well. The option to get a writable temporary file system, basically in RAM, can be now used with the test section for tests that need to be able to write to the container file system. So there's a number of different sections when you build a Singularity container. Test is one of them that allows you to specify certain different commands, things like that you want to run when the container builds so that it automatically does a test. So you can now use tests with that need to write to the container file system with the writable tempfs option. There's new bind mount options to increase compatibility with other runtime CLIs. So this is kind of a new way to just specify directories that you want added or bound into the container you want to run or something like that. This also allows for bind paths with certain special characters, like I said, increasing compatibility. And then the apply cgroups option can be used on systems with the version 2 unified cgroups hierarchy. You still have to specify things in the cgroups v1 format, kind of in Apptainer's configuration stuff where you do this, but then it's translated to v2 and there's compatibility for that now. So this is everything I had on here. Yeah, so obviously a lot of new features that have already kind of been added to this, especially surrounding HPC capabilities, like I said, with DMTCP and GPUs and stuff like that. There's, like I said, lots more on the roadmap and lots more to come. And so we're very excited to see this release candidate potentially get converted into a release here pretty soon. So to kind of touch on the kind of near, maybe more long-term plans for what's going on with Apptainer. And the primary goal for the moment is obviously to continue project stability after the move and get that 1.00 release proper out in a stable state that people can get on and use. Once that's out and that's been tested and well, it's being tested right now, but once that's out and it's been used and we're kind of moving forward with subsequent releases, there are numerous new features on the roadmap, which I've also linked at the end. And like I said, I'll find a way to make that link available. There are numerous new features on the roadmap, generally more options around security features. So perhaps more options for signing keys, more options for encryption keys, maybe the ability to encrypt overlays or something like that. Continuing to improve support for high performance computing and emergent high performance computing technologies. I know there's been some talk of improving the InfiniBand support to be even better than it is, and some few other things along those lines. There's some code base cleanup that has been discussed, kind of just renaming of packages, versioning, that kind of thing that just kind of needs to be done over time to ensure that there's a stable future for Apptainer to build off of. And yeah, like I said, the tentative roadmap can be found in the links. There's more, but for now, those are kind of the high level of what's being focused on. And as I've said a couple of times, there's much left to be explored of Apptainer's new home. Obviously being in the Linux Foundation, as I alluded to with the CNCF and OCI and OpenHPC and stuff, there's obviously a lot more kind of spaces that Apptainer will now be very easily in, and will have a way to interact with people and places and organizations of. So we're very excited to see what's left to explore of Apptainer's new home. There's definitely a lot left, and yeah, so that is the end of the information that I had here. As said, there's a few links there. I'll make sure that those are available. But at this point, I want to say thank you for everyone for being here and for listening. And once again, to the people who set up this conference for getting this set up and giving us the opportunity to speak. As said, I have a couple of members of the Apptainer TSC here to kind of help maybe answer questions. That's Dave and Ian. So thank you both for being here. Without further ado, I will open it up for questions. Thank you all once again. Let's see here.
Hi, thanks a lot for the talk. This is, let's say, an interesting move and probably a very painful move in the short term, but long term, I think it's a good idea to distinguish yourselves a bit better. And also the name is way better than Singularity, which is a nightmare to Google, for example. At least Apptainer is something somewhat unique that sort of helps. I had a question on the checkpointing feature. So that's, I understand, new in Apptainer, was not there in Singularity.
Yes, that is new in the Apptainer v1.00 release and was not there previously. So yeah.
Yes, I can speak on that a little bit. So that's included in that will be included in the v 1.0 release. It's currently marked as experimental because we want to get more feedback on the feature before we declare it stable and lock down the user interface of it. So if people try it out and there's any issues and things that need to change in terms of the implementation in order to make it work for their use cases, we want to be able to iterate quickly on that in order to cover them.
How well has this been tested with let's say more advanced stuff like GPU jobs and MPI jobs? Do you have any idea?
This has mostly been tested on single node jobs. So the complexity with MPI is something that we're still working through in terms of having proper support with that. We're, at least myself and a couple others in the Apptainer, like Sphere, are talking to the original implementer and maintainer of DMTCP and members of their group in order to try and work through what makes the most sense from a container first standpoint of using this technology.
I guess it needs DMTCP outside of the container, so you need it in the host, so you can checkpoint the whole container, or can you say something about how it works?
Yeah, so DMTCP will be injected from the host into the container, so there is a glibc compatibility requirement there for the container image itself. This is similar to the requirements for when we're doing GPU library injection. And part of the reason for this is because I anticipate the need for DMTCP to be aware of host libraries like InfiniBand implementations and things like that.
And do you also know which DMTCP version is being used? Because I mean, we've been looking at DMTCP for a while now, and the latest stable release is now quite a while ago. I think it was 2019, even the 2.6 release. But there seems to be active development towards a 3.0. So are you trying to be compatible with 3.0? Are you using a development version, or how does that work?
The goal is to be compatible for the 3.0 when that's ready. So all of my work and testing has been primarily on the tip of, I think they have a master branch. But when I've tested with the tag release of DMTCP, that also works from how we interact with DMTCP standpoint. There have been bug fixes and things like that that have been brought into the project since that point release that are beneficial. Okay, but you're saying it basically works with the 2.6 as well? Yes. Okay. And do you happen to know the timeline for the 3.0? Because that's been in the works for quite a long time, I think. Yes, I do not. I can't make promises on their behalf, unfortunately. Okay. Thanks a lot. Yeah, I think this is going to be a very interesting feature for lots of people. Yeah, I'm definitely looking forward to the feedback and seeing how people want to use it for their use cases. Thanks.
Apologies, everyone. I was trying to open the chat and accidentally messed up the recording. So my apologies on that. Yeah.
Just asking somebody else to unmute as they want to ask a question.
Hello, I have a question. It's related. Do you guys are thinking just because sometimes it's difficult to handle with several layers to make it Apptainer work in with MPI workloads? So there is something in the path to make integrate or work together, like job managers like Slurm or things like that, to make that more transparent for users?
Yeah, so and that's referring to Apptainer, correct? Making Apptainer more transparent in that way.
Yeah.
Okay. To be honest with you, at the moment, there's already, I believe, quite a bit of what you're asking about out there. I think you can use, Slurm. These containers are basically just used within, Slurm SBatch or something like that, as you would use more or less a, it's like a standard executable. You just use the Apptainer commands inside of it, like, exec, which allows you to run commands inside one of these containers, that kind of thing. I believe that you would basically just take, your SBatches and use these containers with the runtime, basically like how you would with just an executable. But does that answer your question?
Well, sometimes most of the time you have also to handle with host files and with the communication between several containers that are running different nodes. So it's a layer that's not transparent for users, for instance. So, and I was looking for some documentations, and I see that there is a lack of that. It's important in the sense with which that Apptainer is application targeting HPC workloads. So I think I would like to know if there's something in the roadmap for that.
Well, I know there's been a lot of work that's been done on kind of moving the different documentation and stuff like that over, so that Singularity documentation is kind of more easily discoverable as Apptainer. But I also, just to elaborate a little bit on what's kind of in there, it discusses, for example, InfiniBand support, so that kind of cross-node communication. That requires the InfiniBand, Mellanox OFED driver to be installed inside of the containers that you're wanting to use with the InfiniBand network. It requires, there's a couple different approaches to getting MPI in there, that kind of requires some version matching between the host and the container itself on that. So there's, definitely some info out there. Like I said, that documentation is being moved over. So that should be easily discoverable. And I know we'll look to, do whatever improvements that we can in order to make sure that that's clear and easy for people to be able to get online with their HPC use cases.
Great, thank you.
There's a follow-up question on the checkpointing support in Slack as well, which I think is interesting. So Sam is asking whether checkpointing a container is easier than checkpointing normal applications because everything is contained. Does that help?
So I would in general say it's maybe slightly harder from the container standpoint, just because you have to deal with namespaces. DMTCP as a checkpointing project is not integrated to target specific namespaces when it's doing its checkpointing like other projects like CRYU are. But if you have it within the container, it works the exact same as if you were checkpointing from the host. So it's about the same. There's just a little bit of setup that I would say would cause the container use case to just be a little bit more complex.
Wouldn't it help with actually restoring from a checkpoint? Because I remember running into cases in the past where restoring from a DMTCP checkpoint was failing because of PID clashes, for example. And that's probably something you can work around in a container environment.
That is curious, because the way my understanding of DMTCP being architected is that restart PID issues shouldn't occur unless maybe there's something going on at the application level recording process PIDs. But the way the restarting and restoration process for DMTCP is supposed to, in a sense, virtualize those when it's restarting processes and threads.
I remember there was a case where there was indeed an application that was aware of its PID and got very confused when it was restarted.
Okay, in that case, then
the different PID. Yeah.
Then running in a PID namespace might be really beneficial.
Yeah, that's
that
how I can imagine it would help. Yeah. All right. Yeah, thanks for clarifying that.
Yep, thank you.
We have any other questions, Simon?
I'm not seeing anybody. Does anybody else have any other questions?
Well, the last one I had is, if I guess this is already properly documented for the release candidate. If people want to play with this, how to get started with that and what's supported already for the checkpointing specifically.
That was a question about what's currently supported with this checkpointing scheme, if people are looking to get on with that release and kind of mess around and test with it.
Yeah, whether it's properly documented already or is the user-facing documentation still a work in progress?
The user-facing documentation is still a work in progress. The actual PR that I submitted has basically how to get started guide. We were in the process of renaming the user docs while I was submitting the PR, so I didn't want to do that twice and try to deal with collisions and rebases. So the actual PR itself is a pretty good get started guide, but the user-facing documentation that will be available on the Apptainer website is still a work in progress.
Okay.
And all of the Apptainer documentation, just in general, will be up to date when we do our v1.0 release. Right now, we're updating it in parallel to the RC being tested and used. But before actual release of v1.0, that documentation will be up to date.
So I guess if people want to play with this, a good place to get help would be the Apptainer Slack.
Absolutely.
Yeah. All right. Thanks. Yeah, I'll stop asking questions now.
Looks like we have another one in Slack here. Regarding parallel jobs, the MPI ABI is the problem. Let's see, regarding parallel jobs, the MPI ABI, e.g. OpenMPI/mpitch is the problem. I am not 100% sure exactly what the term ABI refers to in that context. So you're basically just saying the MPI implementation.
I think it's referring to the application binary interface. So the interface between things like shared objects. I didn't catch the question though. It sounded more like a statement. If you could.
Yeah, here, hold on. There's more
Rephrase
coming
it.
in on it. It's like,
And I think the question is basically how compatible does the MPI outside and inside the container have to be? So like an OpenMPI 4 on both sides works, but a 3 inside and the 4 outside, or the other way around.
yeah, in the hybrid MPI approach, it's best to match the MPI versions inside and outside of the host. There's another, I think, way you can implement MPI that involves like binding the host libraries in, but I believe the hybrid model is the one that most people go with, and that is kind of the easier way to go about that. So basically just the the MPI version inside of the container needs to be the same one as outside of the container or on the host for maximum compatibility. Between like OpenMPI 3 and OpenMPI 4, I'm not sure if I would expect to see that work too well. I'm not 100% sure about exactly what the compatibility between OpenMPI versions there is though. But I know that in our docs and stuff, you'll find basically just make sure it's the same the same MPI inside the container and on the host that the container is running on.
I think even between minor versions like 4.0, 4.1, you'll see problems. So you better keep it as close as possible.
It's very sensitive, running across dozens, hundreds of nodes at once. So it takes a little bit of setup there to make sure that works correctly. So, Slack.
All right, just having a look. I think that's all the questions, unless anybody else has another one. Thank you to Forrest and to Ian and Dave for giving us information about the Apptainer project. We'll take a break there before the next talk.